Hi, so in this session we are going to discuss another application of bits. So this is remove all set bits from LSB to I. Okay, so the question is you will be given an n and you will be given an I. So you have to remove all the set bits from least significant will be the rightmost bit to ith position. So if your n is like this 0 1 1 1 0 1 0 1 1 0, okay, so you have to remove, clear, let's say you have an n here like this and I is equal to 3. So you have to remove all the set bits, means you have to convert this into 0 1 1 1 0 1. This 0 will remain same here, this will become 0 0 0, something like this you want. This will be your final output and you have to convert this into this. Okay, from ith bit to the least significant bit all should become 0. That is what you want. Okay, now for this we can use a simple thing that we know that x and of 0 is what? 0. So we have to make all of these as 0 and x and of 1 is x. So I think we need to keep this as same and we need to convert all of these into 0. So we will use like AND operator, this will be converted into 0 and we will use 1, this will be converted into x. We need to use like that. Okay, now for converting this into this, so I think I will need a mask which will be like, here I want all ones, 1 1 1 1 1 1, these all are ones and these all are zeros. If I was able to find this mask, I will just do n and of m and I will get this, because these all are ones, so that will be x and 1 equal to x, so this will be same, and these all are zeros, so x and of this will be 0. So I need to generate this mask. Now how will I get this mask? I will get this mask using this only. A is equal to what? Let's say n is this 0 1 1 1 0 1 0 1 1 0, something like this. Okay, now this is my ith bit. How will I get that? What is the ith bit? How will I get that? You have done already check ith bit question. So in that what you did was, let's say you have a you did that this will be my ith bit. Let's say all of them rest of are zeros, something like this. So what you did for that? You did like left shift I times 1, left shift I times. So you get 2 to the power I. So you got this ith bit using by left shifting. You got this A. Okay. Now for generating this m, you want all of them as ones. This should be 0 and this should also be 0. So for that I think we need to do generate B, that will be A minus 1. What is the special condition of n and n minus 1? We had discussed in the previous session as well. From the first set bit, this will be inverted. These all are inverted. 1 1 1 will be, these will become 1 1 1 and these all will remain same, something like 0 0 0 0 0 0, something like this. Because these all from the left part of the first significant bit, first set bit, you will find out that will become 0. At the right part, those all will become inverted, something like this, and these will remain same and that are kept same. This is how A minus 1 is generated. If you know n, you can generate n minus 1, calculate the first set bit, convert that into unset bit, and the right part should be inverted, the left part should remain same. You got your A minus 1. If you got A minus 1, for calculating m, I think you can just do what? C is equal to what? Let's say negation of B. It is like all of them will become inverted. So this will be 1 1 1 1 1 1 1 0 0 0, something like this. You got this? Now you are close to m but not exactly m. So for getting m, you just need this part to be 0. So what I am suggesting is you need to get 1 here and you need to generate 0 here, something like this. So what I am suggesting you is, let's not shift I times, let's shift I plus 1 times. So this will become 1 here, this will be 0 here. Now this will be 1, this will be 0 only. You will get this. Now this will become 0 after that. A will become 1 left shift I plus 1 times, so it will be 2 to the power I plus 1 times, like this. Now if this is this, then you are generating A minus 1. So this is my first significant bit, this is my first significant bit 1. So left part will remain same for this 0 0 0 0. This will be inverted this will become 1 because these all are inverted, 1 1 1 1. So these all become 1. This will be inverted, this will be 0, something like this. Now you take a negation of b, you got something like this. Now you got exactly m using this. If you got exactly m, how you got exactly m? So your m will be, you had left shifted I plus 1 times, something like this. Then you calculated minus 1. After that you taken the negation of that. Through this you got your mask. Now your final answer will be n and of m. You got your m using this 1 left shift I plus 1. You take a minus 1. You got this. Then you take the negation of that and you do n and of m. Then you get the answer from which all the set bits from LSB to ith are removed. So just you need to generate this using the concept of this. You need to take a as same. Then you had used this. You had taken a. You had taken n like this. You had generated a by left shifting I plus 1 times. We had seen that why we need I plus 1 times. After that, you just do a minus 1. How a minus 1 is generated? You go to the first set bit, that is inverted. Left part remains same. Right part becomes inverted. Something like this. Then you take the negation. You got your mask. And if you got your mask, you got your mask like this. And you do just AND with that. And you got your correct answer. Okay. So that is an important concept. I think this was a great application of bits. Okay. You know how to remove all the set bits from rightmost position to ith position. Okay. Great. Thank you.